Hello everyone, this is Amy. Welcome to my math class. Today we are going to look at completing the square. Let's start with monic quadratic polynomials. First, let's see what does monic mean. So for monic quadratic polynomial, we just focus on the term with x squared. If the coefficient of x squared is number 1, then we consider this type as monic. So when we have monic quadratic polynomials, and then we focus on the two terms with x squared and x, and then we are going to complete the square in this way. So for x squared, this one, we are going to separate x and the squared sign. After that, in the brackets, we will need the coefficient of x, so which is number 2 here, and then this number 2 will become its half, and it becomes number 1, so x plus 1 all squared. So we can use this diagram to help us understand. For x squared, it's the square, and then 2x represents these two rectangles. And when we complete the square, the bigger square, and then the size is x plus 1. But when we complete the square, we added this small square. Then this small square, the area is 1 squared, and then we have to minus 1 to make this expression equivalent. And then take away 4 to the end. Then we can simplify this expression. So here we have x plus 1 all squared, and then minus 1 minus 4. It means minus 5. Done. So for this, when we have monic polynomial, so these are the steps for us to complete the square. So first check it is monic. So if it is monic, then we are going to use the second step. So for x squared, it will be separated in this way. So x in the brackets and a square outside the brackets. Then for the term with bx, so the coefficient of x is b, and then this coefficient will determine the constant in the brackets, and we just have b over 2. And then we have to minus this constant squared, which represents the area of this small square. After that, we just simplify. Now let's look at this example. So first determine for this quadratic polynomial, is it monic or not? Yes, it is polynomial because the coefficient of x is number 1. Then we are going to focus on the first two terms. Using these two terms, we complete the square directly. So the first term, x squared, will be separated in this way, x in the brackets, squared outside brackets. Then the constant, we will need the coefficient of x. So for this polynomial, the coefficient is -3, and this value will become its half. Then we will have -3 over 2 in the brackets. After that, we are going to take away this constant squared. Then keep plus 5 to the end because it is the constant provided by the question. Then we just simplify. Then we have x minus 3 over 2 all squared, and minus 9 over 4 and plus 5. So 5 can be converted to 20 over 4. Then we will have minus 9 over 4. Then the constant can be simplified to 11 over 4. Therefore, final answer will be this squared minus 11 over 4. Okay. Then if we have non-monic quadratic polynomial, what can we do? So for example, For this question, the coefficient of x squared is number 2. It is not equal to number 1, therefore it's not monic. Now when we deal with non-monic quadratic polynomials, we have to convert this one to monic. Then same, we only focus on the terms with x squared and x. Then step 1, convert it to monic. So I'm going to write down. So this one, convert it to monic form. Then we're doing this way. So for the monic one, the coefficient of x should be number 1. Then we just make 2 be the common factor outside, and then we will have x squared then minus 3x. Here, because number 6, when the common factor 2 is outside, then we will have 3 left. And then the constant, original constant, put it outside the brackets. Now we focus on the 2 terms in the brackets. It is monic now, and we are going to complete the square by using the previous step. It means the things in the brackets we are going to separate in this way. X squared will be separated into x in the brackets and squared outside brackets. And the coefficient of x, which is -3, it will become a half. Then we will have -3 out of 2. Then we have to minus this constant squared. Then for this number 3, we put it outside. Then we just simplify this expression. For this one, we will have 9 out of 4. And when we distribute 2 to every term in the brackets, then it will become 9 out of 2 plus 3. Then the final answer will be 2 times x minus 3 over 2 all squared, then minus 3 out of 2, because 3 can be written as 6 out of 2. Done. Now let's look at one more question. So if we have 2x squared plus 5x minus 3, we can see this one is not a monic because the coefficient of x squared is number 2. And then we are going to convert to the monic one. And how can we do? Same, focus on 2 squared and 5x. So there's 2 terms with x squared and x. Some of you may think, now number 5, it does not have factor 2. How can we put 2 outside? It does not matter. We just make the coefficient of x squared be number 1. Then if we make 2 be the common factor, in the brackets we will have 5 out of 2. So just have 2 as a denominator. Then it has been converted to the monic one. And then you use the same tip. So 2 outside, and then the things in the brackets we are going to complete the square. So x squared separating this way, x in the brackets squared outside, and now we have the coefficient of x, which is 5 out of 2, and this number will become its half. And 5 over 2 divided by 2 again, then we will have 5 out of 4 positive. And then we just minus this constant squared. After that, we just simplify with this one. I will leave this one to you. Done. That's all for today's lesson. Thank you very much for watching. I will see you next time. Bye.